What's up? What's up? It's your man, Jimmy Chan. Hey, all right, so let's talk about triangles here. So number one, we know that the sum of the angles of a triangle is 180 degrees, meaning if I add angle A with angle B, and add it to angle C, those three angles would add up to 180 degrees, okay? So that is an important fact to know. Every single triangle adds up to 180 degrees. So let's take a look at this example right here. So what we have here is that we want to try to find angle 1, 2, 3, 4, and 5. So I have a triangle here, that's great, but that doesn't really help me because I'm having two missed angles. But then you're like, wait a minute, but I have this right here. And what does that right there mean? This means that this line and this line intersect at 90 degrees. That means they're perpendicular to each other. So therefore, what I would know is that angle 1 is equal to 90 degrees. Well, if angle 1 is equal to 90, then I can figure out what angle 2 is because the sum of the three angles of the triangle add up to 180. So what I can say is that angle 1, which is 90 degrees, plus angle 2, plus that 45 degrees, has to equal to 180 degrees. So then I have, what is this? 135 degrees plus angle 2 is equal to 180. So therefore angle 2 is 45 degrees. Okay. So if angle 2 is 45, so let me go ahead and put it in red here, so we know that this is equal to 90 degrees. Angle 2 is equal to 45. Well, what do I know about angle 2 and angle 3? Well, what I know about angle 2 and angle 3 is that, let me do a line right here. So angle 2 and angle 3 are vertical angles. So therefore, and they're equal. So I know that since angle 2 is 45 degrees, angle 3 must also equal to 45 degrees. Right? Ooh, look at this. Look at what I have now. I got two angles of the triangle here. So I know that these three angles have to add up to 180 degrees as well. Correct? Okie dokie. So let's go ahead and, oops. All right, there we go. We got plenty of space here. So let's go ahead and put it right down here for now. Oopsies. All right, so what I know is that I can say that angle 3, which is 45 degrees, plus angle 4, plus that 60 degrees, is equal to 180 degrees, right? Because there's a triangle. All right, so if we were to do this, we have 105 degrees plus angle 4 is equal to 180. So angle 4 is equal to what? 75 degrees. So now I know that angle 4 what did I say, 75? Yep. There we go. All right, so what do I know about angle 4 and angle 5? That's right. That makes straight angles, right? So, let's up a little bit here. So what I also know is that angle 4 and angle 5 are straight angles. So in other words, they add up to 180 degrees, also known as supplementary angles, right? So I know that angle 4 plus angle 5 equals to 180 degrees. Okay, so angle 4 is 75 degrees plus angle 5 is equal to 180. So therefore angle 5 is equal to 105 degrees. So there we go. So now I know that this is equal to 105 degrees. All right. So now I have just answered all the questions of the measures of each of those angles that they were asking for. All right. So that's how you would go about doing it. Take it a piece at a time. You see a triangle, what's next to it, what's across from it, and then that way we can find each angle individually. Okay. Now, triangles are also classified by sides and versus classified by angles. Okay, you gotta call them appropriate names because of it. So when it's classified by sides, we have the isosceles triangle. It means that the two sides are the same. Now, with triangles, because the two sides are the same, it tells me that the opposite angles are also the same. But because we don't classify them as by angles, we wouldn't call it that. We would just leave it kind of alone with the sides, but the fact that their angles are also equal, we kind of have to know that fact, okay? Now, over here, we have the equilateral triangle. Now, equilateral has the word lateral, means side, okay? So, equilateral means equal side triangle, all right? So, that means, as you guys can see, that all three sides are exactly the same. So going with the philosophy of this, where because the two sides are the same, the opposite angles are also the same, well, the same philosophy goes here. That means this angle is the same as this angle, which is the same as this angle. Oopsies. Okay, so these three angles are also the same. Now we have the scalene triangle, which means that none of the three sides are equal at all. So which means that none of the three angles are the same. All right. Okie dokie. Now, classified by angles, well, it's all based on the angles. So if you look here, an acute triangle means that all three angles are going to be less than 90, just like the word acute. Okay, so all three angles are less than 90 degrees. Right triangle means that you're going to see this little square on one of the corners, and that means that this is a right triangle, which means that there is one angle that is actually 90 degrees. And obtuse, just like the word obtuse, it's greater than 90 degrees, so there is one angle that is larger than 90 degrees. So that's how you know it's obtuse. Okay. Now, similar triangles. Similar triangles are two triangles with equal angles, but might not have the same sides. All right. So if you look at these two triangles here, they have the same exact angles. So if you look right here, I could do it this way. So if I take this right here and I move it on top of this, you see the angle E is on top of angle B, that side C is underneath side F, angle D is on top of angle A, side E is with side B, and angle F is over angle C, and side D is on top of A. So that's how you see the corresponding angles and also the corresponding sides. And then I know that you guys can't do that from your notebook of just picking up the triangle and just laying it on top. So now the other part of it is that as we label a triangle, right, if you notice that the angles are all in caps and the sides are all in lowercase, and those lowercase are always opposite the angle, right? They always look that way too. So this is big angle C, that means this is lowercase side C. Big case or capital B for the angle, while opposite of that is lowercase b for the side. Similarly on the other triangle as well. So if we look at corresponding angles, as I said to you that A was going to be on top of D, right? So if I do this and I put it on top, and you see that A would be on top, or D would be on top of A on top of D, doesn't really matter, but if you notice that I marked it to be the same angles, and this is a good point to bring up too. So to mark what are similar or the same equal angles, we usually mark the angle and then we put however many slashes through them. So like for example, B and E, those are the same, so I put the angle and then put one slash through it. Then when I did C and F, I put the angle with two slashes through it. Then here I put three slashes through it. Okay. Says again, it says that equal angles. So the angles are all the same, just the sides might not be the same. Okay. And so B is with E, which makes sense. B is with E. C is with F. Okay, I even marked them with different colors as well. And corresponding sides, same thing. You see B and E, you see A and D, you see C and F. All right. So, nice part about similar triangles, and the reason why they have similar triangles is because their corresponding sides are actually proportional. So, meaning that if I put A over B, that's going to be the same ratio as D over E. So, purple over red is the same as saying purple over red. Or you can just say the ratio of D to A is the same ratio as E to B. Okay, the ratio of D to A is the same as F to C. Okay, so I put down the proportions right here for you, and I have an example right here where I need to find CA. Okay, so one of the things I was thinking about doing was, let's go ahead and just take this triangle right out of there, right, and go ahead and label those sides. So number one, let me bring these with it. There was C, this was B, and I know that this side is 3, this side is 3, and what I'm looking for here, because this would be A, I'm looking for CA, so I'm really looking for that right there, right? In fact, let's go ahead and put that in red so I know that is what I'm looking for. So when I put this on top here, right, you can see that the X corresponds with the 15, right? And this bottom 3 doesn't correspond to anything because I don't have the side of AD, but I do have this side right here, and those correspond, okay? So as I look at it, that's what I got to remember, all right? So let's do this. Because of the X being that side, I know it corresponds to this side here, okay? And the 3 of BC corresponds with ED, all right? And if you notice that I can say that angle E is equal to angle C. Angle A and angle A are the same, clearly. And then angle B is equal to angle D. All right, so this will help me with the corresponding. So if you notice the red and the blue, all right, so what I'm going to do is now write my proportion. I can say that 15 over x is equal to 9 over 3. Okay, so if you notice, this is in red and this is in blue that I highlighted. Okay, you see that? So how do I figure out proportions? You guys can do cross multiplication. This is one of the only few times that you guys can do that. So what I have is that this right here. Okay, let's try that. Let's try this. Yeah, there we go. So 9 times x is equal to, trying to find the right colors here, is equal to 15 times 3. So what do I have here? I got 9x equals 45. So x must equal to 5. So the side CA is equal to 5. And that would be my answer. And that would be my answer. And that would be my answer. There we go. Whew. Sometimes I struggle with that. All right, there we go. All right, last thing. Pythagorean Theorem. Now, most of you guys already know Pythagorean Theorem, right? Now, notice I labeled the angles with capital letters and the opposite sides with the lowercase of those letters, right? Now, A and B, as you see, are the shorter legs, and they're called legs, and the C is always the hypotenuse, and what you'll realize that it is always opposite the right angle, okay? It's always opposite the right angle. So that is called the hypotenuse, all right? So in class, I would show you guys how to spell hypotenuse. Some of you guys already know how to. So we'll actually learn how to spell it so that you will never forget it, all right? So again, A and B are legs, C is a hypotenuse, and the formula for that is what? That's right, A squared plus B squared is equal to C squared, okay? Now notice that the hypotenuse is all by itself. So in this equation, you know what? Better yet, there we go. The hypotenuse is always by itself on one side, okay? So, for example, if we were given a problem, let's say that they're looking to see if, how wide this lake is, and they want to know, actually I gotta fix this a little bit here. They don't want to obviously take the tape measure and jump in the pond and figure out how wide this lake is. So what they're going to do is they're going to just find a point where they can just not walk it out, but figure out how far they are from this particular point here. Okay, so they're going to stand right here. And what they want to do is find out how far this distance here is, which you can see that it's going to be 20 miles. And then they got to figure out what this distance here is. And they figured out is 27 miles. So now what they want to know is find out how wide the lake is, right? So you guys always talk about real life applications. Here it is. It is literally right here. And we know that that is a 90-degree angle. So we have a right triangle here. So what I can do is saying, okay, so what do I have? Which one of these are hypotenuse? And again, this would be my hypotenuse. Wow. All right, we're just going to leave it that way. This is my hypotenuse in use. Okay, so that means if I use the Pythagorean Theorem, it'll be a squared plus b squared is equal to c squared. So does it matter if I call this a or this a? It does not matter, okay, because it's all on the same side and we're adding, so it really doesn't matter. So I would tell you to just go with x squared plus 20 squared is equal to 27 squared. All right. So I have x squared plus 400 is equal to 729. So x squared is equal to 329. And the question is that a perfect square or not? It is not. So now, here's the thing I want to bring up is this. Let me go ahead and duplicate this so you guys can actually see. Now, don't forget that the opposite operation of x squared is the square root. And because I'm taking the square root of this side, I have to take the square root of this side. All right. Now, typically, there is going to be a plus and minus that I have to add on here. Every time you take a square root, you have to have a plus and minus. However, because that this is a length and not we can never have negative length, that's why you wouldn't use the negative. You would reject the negative anyways, okay? So, therefore, we're going to have x is equal to plus and minus 18.1, about 18.1 miles, okay? And again, the negative one gets rejected, so we can just say x is equal to 18.1 miles because length is not going to be negative. So it's 18.1 miles, so it'll be a tough swim to make it across that lake. So, but it'll be a very good workout as long as you have someone there to watch you. All right. Well, hopefully this helps you. If you have any questions, please let me know. Talk to you later. See ya. Bye.